Hannah sells a few goats, okay? She decided, you know what? The flock's gotten too big. I've got 60. I'm selling 10 of them. I've got to make some money. She makes $1,000 on the goats. She decides she's going to invest them. She's going to invest it, and she makes 5% on that $1,000 investment. 5% is how much of $1,000?
50.
$50. She gets $50. She decides that's a good deal. I'm going to leave the investment in there. Next time, she doesn't just get 5% on 1,000. She gets 5% on 1,050, right? And it continues to compound over and over and over again. Compound interest is a good thing. And when we're dealing with money, we work with this formula because we compound money every so often. P refers to your initial investment, which in this case was $1,000. R refers to the rate at which you invested, which was 5%, or we put 0.05. N is the number of times it's compounded on a given year. We would say in this, it would be annually, so once a year. And then T is the number of years in which you invested. Not everything works out like that, though, because not everything just kind of grows every so often. For example, let's talk about bacteria. Where can you find bacteria?
Lots of places.
Give me some examples. Hands, bathrooms,
Door handles.
phone. Very good. Do you think that the bacteria on your phone, do you think that they sit there and they say, you know what? We're going to wait till 9 o'clock, and at that point, we're gonna duplicate. All right, we're going to wait till Wednesday before we decide to grow again. Or does your bacteria grow continuously? Continuously. So look at the continuous formula. What's different about this formula compared to this formula? It has the letter E. E is the base when you have continuous growth. It represents what happens in nature with continuous growth. Nature, thus the term natural logarithm. Everybody see that? So here we go. We have a radioactive substance that decays. Starts out at a certain amount and it decays over time, where the amount of mass remaining after T days is given by this equation that I see right here. Mass is equal to 23 times e to the negative 0.0043 t. And mass is measured in kilograms, and again, t is measured in days. Okay? It says find the initial mass. The initial mass is what happens at what time? What time do we think we plug in if we're looking for the very start? The very, very, very start. If I'm starting a clock, what time do I start at? 0. So we're wondering the mass at time 0. That would be the initial mass. Sometimes we're going to need our calculator for this. Sometimes we won't. In this situation, I take 23 times e. What is negative 0.0043 times 0? 0. So you have 23 times e to the 0. What is e to the 0?
1.
Anything to the 0 power is 1, so you get 23. So 23 kilograms is our initial amount. Notice how this equation involves E because as it's radioactive decay, it's decaying all of the time. It's not every so often, it's all the time. How much of the mass remains after 21 days? Is it going to be more than 23 or less than 23? Less than 23 because it's decaying. So the mass at day 21 is equal to 23 times e to negative 0.0043 times 21. Now that I would just plug into your calculator. So I'm going to go ahead and grab my calculator. I have 23. The E button is right above natural log. Negative 0.0043. I'm going to multiply that by 21. And that tells me after 21 days, I have 21 kilograms left. 21.01. Any question how I got that? Are we okay? Now look at the next question. How many days does it take to have a mass that is half the initial mass? What is different about this? What am I solving for here? I'm solving for the time, right? It says after how many days? This is what I'm wondering. How many days does it take to have a mass that is half the initial? So I know the mass in this situation. I don't know the time. If the mass is half of the initial mass, what is my mass? So 11.5 is equal to 23e to the negative 0.0043 t. That is my equation I'd like to solve. Please pause for a second and recognize that a week ago you had no clue how to solve that, and that looked extremely challenging. Is anybody scared about solving that now? No. Okay, what do? Divide by 23, and I get 1/2 is equal to e to the negative 0.0043 t. Now I take the natural logarithm of both sides. And I get negative 0.0043 t is equal to, and on the other side, I have the natural log of 1/2. Somebody on their calculator, natural log of 1/2.
Negative 0.693.
So I have negative 0.693 is equal to negative 0.0043 t. I divide both sides by negative 0.0043, and I get t is equal to, I think I remember from last hour, it was like 161.1?
0.2.
0.2 days. $161 days, it will get down to 11. That's actually kind of a chemistry or physical science type problem right there. Okay. Let's get to money. $1,500 is invested at an interest rate of 8% per year. It's compounded semi-annually. Find the value of the investment after 5, 10, and 15 years. So I'm going to write down my equation. The amount is equal to the principal times 1 plus the rate over the number of times it's compounded, raise it to the nt power. Notice I've chosen this formula because it doesn't say that our interest is, or that our money is compounded continuously. It's every so often. So I'm wondering the amount. What is the principal? What's my initial investment? $1,500. At what rate is it invested? So I put in 0.08 divided by how many times is it compounded each year? What is semi-annually? It's twice a year. Twice a year. That's that reference. Raised to the, and then n is 2, so 2t power. 2t power. Now, I don't want to have to do this 3 times. I want to do this really once and make it quick, okay? So it's 5, 10, and 15. I'll show you what I like to do in this situation. The amount is 1,500 times, and 0.08 divided by 2 is 0.04, so 1.04 raised to the 2t power. Right away, I go to my calculator, and I go into y equals. And when I'm sitting in y equals, I type in that function that I wrote, which was 1,500 times 1.04 raised, and here's where you got to be careful. When you use this in the exponent, make sure you got parentheses around the 2 and the t. You're okay with that? I want to plug in 5, 10, and 15. So I'm going to go to my table. Table is second graph. And once you get to your table, you should be able to just type in 5, 10, and 15. And if you actually hover over those numbers, you can see that below it expands the numbers further so you could get a more accurate amount, but those 3 are your answers. Anybody having a problem coming up with that? Anybody having a problem with their table? Okay. Usually we got a couple things that might be going on. Maybe your table values aren't going up. So right now, your calculator is automatically generating these. So what you're going to do is go to your table set. See how it's auto and auto? You're going to set that one to ask.
What that meant is you can
the independent one to ask. As you go to your table, now type in 5, 10, 15, you should get it.
It's still the same. You gotta do problem one.
You must have typed in the y equals equation incorrectly. So you have 2 times 10. You just want to put x because that's a variable that we're to change.
Okay.
So now as you go to your table, now you get those.
I'm just wondering, how do I delete the old ones? Like, I put
Just, nope, and it's just your calculator wants you to press delete.
Thank you.
Yep. Everybody okay with that? Okay, then we are going to flip to the next problem. We're skipping problem 3. And 4, 5, and 6 will wrap up our unit. You guys have done a great job. 3 college credits to your name. Does that feel good? Yeah? College student? Let's go. All right, a man invests $2,000 into an account that is compounded annually at an interest rate of 5.5%. What is the amount of the investment after 4 years? I want you to take the problem up to that point and see if you can just find that. Use the formula that we've been talking about and do just that part.
Per year, so it's 1, 2,
Okay, so I should see 2,000 times 1 plus 0.055 divided by 1 raised to the 4 times 1 power. Is that what you had set up in your equation? The mistake that some people make is they don't write 5.5 as 0.055 for the percent. Sometimes they write as 0.55, but move your decimal point 2 places. So 2,000 times 1.055 raised to the 4th power. What'd you come up with? 2,000?
2,477. Oh, and I forgot the decimal places. Oops.
Anybody got a decimal on that?
165.
My bad.
Any questions how we came up with that?
No, I just didn't.
Okay, then we go to the next part. How long does it take for the investment to double? Notice the difference in this question. We're solving now for time. So if the investment doubles, what would it be worth? 4,000. So 4,000 equal to 2,000 times 1.055 raised to the t power. That's our equation. What do you want to do?
Divide by 2,000.
Divide by 2,000, get 2. It's equal to 1.055 raised to the t power.
Log of 1.05. The log base 1.05.
Excellent. So that's a correction I made in other classes. It's not log of 1.055. It's log base 1.055. Ben has corrected himself there. Good job. We cancel those off and we get t is equal to And, you know, we know how to calculate log base 1.055 of 2. We just take the log of 2, divide by the log of 1.055. If I remember correct from the other hours, we get 12.95. So 12.95 years it's going to take for that investment to double. You might say, well, hey, I can wait the 13 years. Maybe you can't. You got to decide what you're going to do with your money. But at least you get to make the decision. Okay? Questions? Okay, slightly different problem. An investment of $800 was compounded quarterly over the course of 6 years. The investment resulted in $1,245.83. What was the interest rate of the investment? Okay, so we have amount is equal to the principal times 1 plus r over n raised to the nt power. Okay, what I would like you to do is I would like you to plug in the numbers and figure out where do the numbers go and which variable are you solving for. Talk to the person next to you if you need to, figure out where they go and what you're solving for.
Yeah.
Okay, let's pause there. I've got the $1,245.83 off to the left-hand side. I have the principal at 800. I have 1 plus r over 4. Why do I have 4 in the denominator? Compounded quarterly, so that means 4 times a year, so I put 4 there. And then I get 4 times 6, because it's 4 times a year, 6 years, so it gets compounded a total of 24 times. So I want to solve that. How are you going to solve that? Got to solve for r. Divide by the 800, good, and you get 1.557 is equal to 1 plus r over 4 raised to the 24th power. I've got to access the r value. How? Don't divide by 24. Don't take the log of 24. Don't take the log base 24. You can't move this out front either because there's not a logarithm. You can't just take things and move them out front anytime. There has to be a logarithm. Cube root, you're on the right track. 24th root? Yeah. May seem weird, but if you want to get rid of an exponent, you take that root. So I have the 24th root of 1.557. 1 point is equal to 1 plus r over 4. Oh, I'm sorry. I'm just skipping by. A lot of people are probably wondering right now, how do you take the 24th root? Is that accurate? Sorry about that. If I go to my calculator and I go 24th root of something, so we have the 24th root of, well, what is it, 1.557?
Yeah.
Okay, so I have 1.557. There's a couple ways to get it, but what I like to do is I like to raise it to the 1 over 24 power. So that's what I do when I want to take a root. So I just raise it to the 1 over that power. Is that what you did, or did you grab the? Okay. So the other option is to do your In math, you have number 5 gives you whatever root you want. So you put a 24 first, okay?
You put 24 and then you do
And
that.
then you do, yeah,
Okay.
that's another option, yeah.
That's what I was trying to figure out.
Okay, good. So then we, next we subtract our 1, I get 0.019 is equal to r over 4. And finally, we multiply both sides by 4. And my good old math told me that was 0.076 is equal to r. So what's our interest rate? 7.6%. Any questions on that one? You ready for the last problem of your unit? Way to go. It involves rabbits. I love rabbits. Rabbits have like 4 jobs, right? Eat, sleep, multiply, and poop.
Pests.
It's like it, right? Pests.
Yeah.
You got rabbits on the farm?
I don't.
Do you know Margot Wayne?
Yeah, I do.
She loves rabbits.
She's my favorite.
Yeah, she is the best. I love her too. All right, so we got these rabbits, and they're modeled by this function. Their population is, and P is measured in thousands. It's the number of rabbits since it's been tracked, the population after 10 years we want to find, and we want to find how many years it takes for the population to reach 8,000. I'm going to add a part to this problem, very easy part, and that is I want to find the initial population as well, the initial population. If I want to know the initial population, what number do I plug in? I plug in 0. And we get 30 divided by 1 plus 5e to the negative 0.3t. I replace t with 0 as I'm plugging 0 in. And this is one we don't really need our calculator for. Negative 0.3 times 0 is 0. E to the 0 is times 5. 5 plus 1. 30 divided by 6. So the population starts with just 5 rabbits.
5,000.
5,000, measured in thousands. Very good. 5,000 rabbits. Yeah.
Sorry, I'm backtracking, but why did you start with 0 again?
So I'm adding to the problem instead of just finding 10. I want to start by the initial population. Okay. I want you to have a frame of reference. When I first did this problem, that's what I was drawn to, is like, okay, I have what it is for 10, and you're going to see why I asked the initial in just a second. Then.
Okay.
Now I want to know the population at 10 years. So I'm going to plug in 10 for the value of t. I have 30 over 1 plus 5e. And what is 10 times negative 0.3? Negative 3. So that's one I can't just do in my head. So I'm going to need to use my calculator for that. We want to make sure that you plug it into your calculator correctly. I have 30, and I divide that by, anybody know what I do next? I need to put parentheses for the denominator. 1 plus 5, remember where your E button is, and that we said is to the negative 3 power. And I press enter, and I get 24,020. So that would be 24,020 rabbits. Some people asked about the maybe 0.45. I said I don't like to talk about 0.45 rabbits. It's like roadkill. Nobody laughed last hour with that. I thought, what's that? I did. I thought it was, I thought some people kind of picked up on it, but I don't know. Maybe I was getting a little bit boring last hour. 24,020 rabbits. What changes in the next one is how many years does it take for the population to reach 8,000? So now we know the population. We're trying to solve for the time. What are you going to do? How do we set this up?
X equals 30 over don't know.
What is our population?
8,000.
8,000. So what number do I plug in for P?
Oh, I didn't realize P was the.
8.
Whoops.
8. I plug in 8 because it's measured in thousands. So 8 is equal to 30 over 1 plus 5e to the negative 0.3t. I've tried to prepare you for this moment by putting a couple of these problems on your assignment. Does anybody know what I do to solve this? Connor, say it with confidence. Cross multiply. I think Hannah maybe beat you to it. Okay, I cross multiply, I get 30 is equal to 8 plus 40e to the negative 0.3t. I subtract 8, I get 22. I divide by 40 and I get 0.55. Evie has told us to take the natural log of both sides to get rid of e. I think the natural log of 0.55 from the previous hours was, I don't know.
Negative 0.59.
I divide both sides by negative 0.3 and I get 1.99 is equal to t. Now in context of the problem, and some people will just leave the 1.99, they won't worry about it. I can't live that way. I have to ask myself, is that reasonable? So when you asked about, doing 0 at the beginning, look at what I was trying to create reference for when I was doing the problem. If at time 0 it's 5,000, and if at time 10 it's 24,000, we're wondering when it's 8,000. Do you agree it needs to be in between that time frame? So I can see it should be somewhere between 0 and 10, and I got 2. Had I come up with 12, it's like, well, no way. We would have passed over that 8,000. So that's telling me some useful information here, a way to confirm my answer. So, nice job.